Okay, so the prep was to find a way of multiplying two numbers together in Little Man Computer. Now, the way that we want to do this really is to sort of have our two numbers. Let's just get rid of that. Have our two numbers. Let's say our two numbers are called x and y. So we've got x and y. And if we've got these two numbers, what we're going to do is we're going to multiply it in such a way that we're going to add as many times as we need to according to the other number. In other words, let's say we're going to have x plus x plus x plus x. We're going to keep adding x, and the number of times we do this is y times. Okay, that's, in other words, y lots of x. So if we're going to do that, what we want to do is to make sure that we're doing this the most efficiently. So for example, let's say we're doing 3 times 100. Then what we don't want to do is we would prefer not to say this is 3 plus 3 plus 3 100 times. We would prefer to have 100 plus 100 plus 100, so that we're only adding something 3 times rather than 100 times. Okay, so in order to do that, so these are our two numbers. We don't know when we're inputting our two numbers which is the larger. Okay, but let's say we always calculate this particular so that we're always going to be calculating this particular calculation. In other words, we want to make sure that we want, if you like, okay, we want y to be less than x. We want to be adding this as fewer times as possible up here, this y times. Okay? So if that's the case, then we want, so if we just subtract x from both sides, we get y minus x must be less than 0. And therefore, we can say if that's not the case, then we should swap. Okay? Otherwise, we swap. X, bit of a crash here going on. 1 second, right. So otherwise, we're going to swap x and y around. Okay, so x will become y and y will become x. Right. So in other words, we swap if y minus x is greater than or equal to 0. Okay, so that's a key thing here. We're going to swap if y minus x is greater than or equal to 0. Okay, so in other words, we need a way of inputting x, inputting y, and then we're going to do this check. So our steps, if you like, are step 1. So steps here. Step 1 is we're going to input x, and we're going to input y. And then we're going to sort of determine if we need to swap. Okay, by doing this calculation here. Once we've done that, we can then use the same calculation each time. So we're going to do our x plus x x y times. Okay, that's what we're going to do. So I've written a program to do that. And let's have a look at it now. So we'll go over to our program, which is here. And let's go through this line by line. So here we have our input x. And then here we're going to have our store x. So, and then we're going to input y and store y. So that's our x and y stored in these two variables. And our x and y are down here, look. Here's our x and y. They're variables at the end of our program. Now, remember when we went back to here, we're going to say, we're going to swap if y minus x is greater than or equal to 0. Okay, so this is like a branching, and we want to calculate y minus x, and if y minus x is greater than or equal to 0, then we are going to swap the x and the y around. And that's what this does. So we're inputting x, then y, and then we're going to subtract x, and we're going to say if it's positive, so this gives us our, if we're subtracting x from y, this is our y minus x, and then we're going to say if it's positive, then we're going to swap. So that's what this is. Y minus x is positive, then we're going to swap. Positive or 0, actually. Obviously, if they're equal, it doesn't matter whether you swap them or not. Okay, so if it's positive, then we're going to swap, which jumps down to here. So we're going to branch positive if swap. So let's have a look at that. Now, if they're not, then they're already in the correct order. X and y are in the correct order to add up x to itself y times. So what happens if that's the case? So if they don't swap, then it's simply going to load y into the accumulator, and then we're going to store that number into something called a counter, because the counter that I'm going to have here, this becomes our counter, is going to count down until it gets to 0 the number of times that we've added this x. Okay, and then once we've done that, we're going to branch to this calculation loop, which actually does the calculation of this step 3 here. Do our x plus x plus x, etc., y times. Okay, so let's just run this for now. We'll come back to the program again. So just going to get rid of that for a second. So we're going to reset that, assemble it into RAM, and run it. So it's asking for our input. So let's say we're doing 3 times 100. Okay, 3 times 100, and what I'm printing out here is the fact that my total that I'm adding up as we go along, in other words, our total of these 2, then our total of these 3, then our total of these 4, etc., is being printed out. 1, 2, 100, 200, 300, then giving our final answer here of 300. Now let's just check, let's just run it again. And this time I'm going to do it the other way around. So instead of 3 and 100, I'm going to do 103. So again, you can see that it only does 100 plus 100 plus 100, making our total of 300 rather than 3 plus 3 plus 3 plus 3 plus 3 100 times. Okay, so let's go back to our program again. So we're inputting our values. We're making a decision whether or not we need to swap them round. And if we don't swap them round, we do this calculation. So we're going to load the counter up. If the counter gets to 0, so if this counter, which is counting the number of times that we need to do this x, is 0, then we go to finished and we output the total and finish. We load the total up and output that and then halt. So the total basically is this x to start with, then x plus x, then x plus x plus x. It's adding up all these x's. That's what we're using this total, this total variable here. Okay, so we're going to load up the total, which initially will be 0, because that's it set to 0 down here. And then we're going to add x to it each time. And we're going to keep doing that until this counter, which is the number of y's that we've got, so this is our counter, is equal to 0. And if it is equal to 0, then it branches to finished, outputs the total, loads the total up, outputs that total, and halts. Okay, so that would work. Let's say if we're adding 100 3 times. If they need to swap over, then we need to do the following trick. So let's say we have got y minus x is greater than 100. So in other words, we've got, let's say our two numbers are 100 and 3. So this is our y and this is our x. So we're basically saying that y minus x, which is 97, is that greater than or equal to 0? Yes, it is. So what we're going to do is to try and swap these two things around. Now, how would we swap these two things around? Well, let's imagine I tried to throw this 3 into this memory location. This has the effect of destroying the 100, and I've lost it. So to swap two things around, what I need to do, first of all, is, just starting again from our 100 and our 3, is first of all, I need to store out one of these into some temporary variable. So that's indicating the 100. So the 100 is stored so that when I copy this 3 over into this location, and this becomes 3, I haven't lost the fact that I've got 100 here. After I've done that, I'm going to put my temporary variable into here, and that becomes 100, and I've swapped them around. Okay? So let's say we were swapping 6 and 75. I copy this out to a temporary variable, and then I swap this into here, so that becomes 75, and then I swap this back into here, so this becomes 6, and I swap them around. Okay, so I can't just throw that into there because I override what's in there and I lose what was in there. And that's what I'm doing in this part of the algorithm here, in this swap bit. I'm loading up y, which is basically loading the y, and then I'm going to store that in the temporary variable, and then I'm going to load up x. So load up this variable x, and I'm going to store that in y. Then I'm going to load my temporary variable, I'm going to store that in x, and then I'm going to load that y and store that in my counter, because remember, y is my counter. Now, the benefit of doing this swap is that I don't have to have this rather more complicated algorithm twice. One for when x is bigger than y, one for when y is bigger than x. Okay? So I'll just swap them around and then carry on with my counter. So that gives you a basic idea about how I approached this particular task.